Dhruvil, and we have taken part in a competition which was arranged by Texas Instrument. The name of the competition is TI Innovation Challenge. We are representing the College of Engineering Pune, and the name of our team means the team number is 468, and our project is a phase sequence detector. Here are my colleagues AKOLKAR and SWAPNIL.
Hello friends, my name is and this is the basic logic behind our project. So these three waveforms are the wave representation of the three phases R phase, Y phase and B phase. Each waveform is divided into 6 equal parts of 60 degrees using the clock pulse of 300 Hz. As this is the wave of 50 Hz, its 6 times is 300 Hz, which is the clock frequency, which divides this wave in 6 equal parts. So if we consider a part from 0 degree to 60 degree, here R phase is at logic 1 and Y phase is at logic 0. So at each interval we get some sequence according to this, that is for 0 degrees we get R phase is at 1 and Y phase is at 0. If we consider R and B phase, then R phase is at 1 at the same point at the 0 degrees, and B phase is also at logic 1. So at all these 6 points we get this sequence, and as the wave repeats itself after 360 degrees, this sequence is also gets repeated after time period, that is 20 milliseconds. So this sequence is further stored in this 6-bit register using this circuitry. So the first 6-bit register stores the data according to the phase sequence of the first source, that is source 1. Here are the first phase and the second phase of the source 1, which stores data according to the phase sequence of that source, while the second register stores the data according to the phase sequence of the second source. After storing of the data in the register, the comparator circuit compares the bits, 6 bits, and gives output. If the phase sequence is opposite, that means first source is in RYB phase sequence and second source is in RBY phase sequence, then the sequence will be different, and the data stored in the shift register will be different, so the output will be 0. If both the sources are in same phase sequence, then data will be the same and the output will be the logic 1. So this is our whole circuit. So now we will see the practical demonstration of our project. So this is the 3-phase source. As we have only one source, we are deriving the 2 sources from single source itself. This is a power analyzer which displays the line voltage of all the 3 phases with respect to neutral. So this is our basically the whole circuit. Here there are 4 op-amps which convert the sine wave obtained from the source to the square wave. Then these waves are fed to these units, which gives the output to the, which operates the signal lines of the multiplexers placed over here. Then according to multiplexers, the data is fed to the 6-bit shift register which are located over here. These 3 ICs gives 6-bit shift register, and these 3 gives the second shift register. And over here there is a comparator circuits which gives the final output. Here the LED is which displays the whether the sequence is same or not. So now I have given the 3-phase supply to the power analyzer. Here we can see the 5 volt RMS voltage is given to the op-amp. So now for the first case we are using only R and Y phase, so as to give the same phase sequence to both the sources. So here is the function generator which operates at 300 Hz square wave, and this DC power supply is used to supply the power to the op-amp as plus minus 12 volts, and the 5 volt supply to operate all the digital circuitry. So now as the phase sequence is correct, when the supply is given, the LED should go, which represents the phase sequence is correct. So now we will see whether it happens or not. So I have given supply, DC supply. Here is here now the LED is glowing, which represents the phase sequence is correct. So we saw in the first case the LED did glow, so stating that the phase sequence is correct. So now we are testing the second case. Here we are using all the three phases. For the first source we are using R and Y phase, and for the second pair of op amp we are using R and B phase. So the phase sequence is now reversed. So now the same procedure. When the DC supply is given, if the LED glows, then there is some failure, but if LED does not go, then the circuit works in this condition as well. So now we will see. So here the DC supply is given, op amp is working at plus minus 12 volt, and all the DC circuitry is working at plus 5 volt. The clock frequency is also 300 hertz, the square wave. And here we can see that the LED is not glowing, which represent the output signal of our whole circuitry is at logic 0 level, which represents that the whole phase sequence of both the sources is opposite. So that's it from the practical demonstration. Thank you.